So today we're looking at the Hyundai L400LMC slant bed 3-axis heavy-duty CNC lathe. It's a large machine with 2.1 meters between centers, and this particular machine is fitted with a Siemens 828D control system with Shopturn, and we're going to demonstrate the features and cycles of that particular control. Looking inside the machine, we can see it's fitted with a 15-inch 3-jaw power chuck, tool setting arm, heavy-duty turret, programmable tailstock, and also this particular machine has steady rest preparation, so it'd be suitable for an SMW 5.1 steady or similar. So the control system is the Siemens 828D with Shopturn, with good graphics and very user-friendly, with the standard Hyundai keyboard layout. So here we can see the heavy-duty tailstock with the machine, with the quill and the revolving center, the turret of the machine, the steady rest preparation, and the 15-inch Siemens chuck, which is a 3-jaw chuck with soft jaws included, and of course the tool setting arm. Heavily built machine, 2.1 meters between centers, and it's a solid slide design on both the X and the Z axes, and we have a gearbox for the 2-speed gearbox for the headstock. Able to walk around the machine. Back of the machine now with the electrical panel and the air conditioning unit. Going down the back of the machine, we can see the hinge type swarf conveyor and the coolant tank. And the machine manufactured by Hyundai, part of the Hyundai motor group of companies of South Korea. Overview of the machine here, the Hyundai L400LMC in our showrooms at TW Ward. We have various other models on the showroom floor at the moment. Some machines are ready for delivery to customers, others are awaiting pre-delivery inspection. So what we've got here is the standard Siemens 828D layout. You have shortcut buttons here for the screens. So for instance, here we go to the offset key, it goes to the tool offsets. If we go to program, it goes to the editing of the program. We can then go to program manager, which is the program memory. Note the 6.4 megabytes of storage still free, and you have a directory of where the component programs are. Programs can be names or numbers. There, for instance, letter O002, or you can just give it an actual name, such as up there, O150 CX1. I've just put the initials there, R1, R2, RS. Right, so for program storage, while we're in that function, we have 3 possibilities. We've got a flash card, we have a USB, and we've got the Ethernet. So that allows us to load or unload programs. So we have 2 options when we come to programming. We've got the ISO program, or we've got the Shopturn. So what I'm going to do here is go into menu select and program. So there we've got the program display. We can, in this case, that's the program that's active. I'm just going to close that down, so that puts us into the directory. So there I'm on a folder which is titled RS, and I'm going to stay in that folder for the moment. You can see we can move the key up and down with the cursors. So I'll put it onto RS. We'll have a new file, and I'll call it, I'll just give it a silly name, 456. You can basically call it whatever you want. It's within Shopturn. So here you've got G-code program or Shopturn. So we'll actually select a G-code program and we'll say OK. So now we're into it, and we've got the functionality down the bottom. We can drill, we can turn, contour turn, milling, simulate. The simulate's very good, we'll come to that in due course. And then we've got all the cut, copy and paste functionality here. So in this instance here, I've gone into various, and I'm selecting now blank. And the blank allows us to get a nice graphic picture. So there we can, it's saying cylinder, but we have the functionality to change it to pipe, a square block, and you'll see the graphics update automatically. Multi-cornered prismatic type shape, or none. So I put it back to cylinder. It then asks you the diameter of the cylinder, and it asks you where the actual various functions are. There it's saying where's the front face, so we put 0 in for that. It's already there. So I'll just move to the next one with the cursor, and it's saying how long is the billet fully, including. So you know the Z1 is larger than the ZB because of the amount that's stuck in the jaws. Once you've actually got that display right, you can then say accept, and it goes there, and that's how it outputs. Now you might ask, how can you edit that? You've got two ways. You can actually just edit the line, or you notice the key here, you can just go sideways on the cursor key and come back into it.
Yep,
so now we're into writing the program. You can actually do the normal sort of moves in G-code, which is, for instance, G0 rapid. We can give it a Z figure to, we'll say, 12 millimeters, and you press input. So you can write a normal ISO program in that format. I'll just take that out because it doesn't make much sense at the moment. And then if I actually now go into, if I wanted a cycle, all I do, I look along the bottom, find the one that I want. For instance, contour turning. I can do contour here, new contour, and you give every contour can have has to have a name actually. So I'll give it, I'll just call it new contour just for the sake of it. Accept that one. So you get the name there, and then what we start to do is we start to fill in the blank boxes. So it's asking for the absolute position here where we've got to start, and 0, 0 is the center line, is that point. So that to me is okay. It's saying it's radius, or you can actually have it as a diameter. At the end point of the line you can have either radius or you can change it to a chamfer. So at the moment that's just only the start point, so it's not relevant as such. We start to build up the profile we're going to turn. So we've got the soft keys here, so I want to do a straight line going up. If I want to go up to a diameter of 50 millimeters, and it's absolute notice, you can do incremental by just flicking the actual selection button here, and it also prompts you here. So I'm going to put that to 50 mil. It automatically selects 90 degrees. We can change the angle if we need to. And it's asking, do you want a chamfer? And again, we can select a radial, but that's for the end point. Undercut. So I'm just going to leave that out. If you don't put anything in there and just press accept, it just means it's a straight line. But now you notice here we've got a little icon indicating the line's gone up. So now we can go a line going left. So there we've got that, and again you give it the dimension of where it's going to, minus 25 millimeters. We can put angles in, we can put chamfers. In this instance what I will do, I'll put a radius of 2 millimeters.
So So this is just using standard cycles to create a G-code program,
well,
Richard?
this is actually just drawing in the cycle as such, or the finished profile, and then it will actually work out the roughing blocks to achieve that stock profile. So I'll accept that one. But it can't do the radius yet, but you'll notice we've got the icon. It'll do the radius once we put the next line. So here we've got a line at an angle, any angle, so I'm going to put line, and go X2, we'll say 75. Bear in mind I'm just making this up on the spot, so I'm just going to give it an angle instead here. And you notice the 0 there, so if I want 45 going that way, it's 90 plus 45 is 135 degrees input, and I'll accept that now. So now I've got the line coming up, the line going along, I've got the radius in the corner and the line going to a point. Okay?
Yep.
And so I can accept that.
And that's created
a
portion of your G-code program. So it's quite simple, isn't it, to actually just use those graphic functions.
Not only that, if you look down
your ISO program.
If you look down here, you've got all the functionality for the C-axis as well. So you've got your milling. I'll just bring that down so it's. You've got your milling cycles as well.
Oh yes.
You've got slots, thread milling, engraving, pocketing.
Pocketing, yeah.
Multi-edge spigot.
Right.
And contour milling.
So that's quite a simple demonstration of how to create an ISO program.
And that's within the ISO functionality.
That's within the ISO functionality.
The various cycles within the ISO functionality. So if we look at, for instance, the milling functions, and then down the side on the soft keys here, you've got thread milling, engraving. So we look at the pocketing for a start. What happens as soon as you bring that out, it asks you the tool number and the feeds and such like. And all you can do is you go down the actual page, just filling in the information that's required.
Right. And
the graphics will then update as you come down.
And what other milling cycles have we got?
So we actually just cancel that for the moment. You've got what they term as a multi-edge spigot. So you've got here a profile as opposed to a pocket. I'll cancel that one out. We've got slots.
Yeah.
Cancel that one out. We've got thread milling.
Right.
Now that's milling as opposed to thread turning, so that can be off-center as such.
Right. That's good. So you can thread
engraving.
Yep. Excellent.
And
right. So those are the milling cycles. What about turning cycles?
On the turning side, if we're going to turning, you've got contour turning. The first turning there is more. If you look up here, you've got grooving, undercutting, and threading, and cut off. You've got contour turning for your profile. So you can actually give it a new contour. So as I open that out, you give it a name, accept that, and at that point then it's going back to building the profile up.
Right.
So if you look at the drilling cycles, let's cast that. Drilling cycles here, we've got on the soft keys, drilling centric on the center line, in other words, centering, drill reaming, deep hole drilling. So we'll look at centering for a start. You select your tool.
Same process then.
Same process, just fill in the blanks. But for instance, the tool selection, if you go to there, it takes you to the offset page.
All right. And
you select the tool that you want, and then say OK, and it transfers it. And it also analyses it when it does the graphics later. Right, so here we've got a create a program in Shopturn. So we select the program mode. There we've got the folders, so we select the folder we've got to put the new program into. Down the side here we've got the soft keys, and so I'm going to say new. And in this case, I'm going to select the Shopturn. I've already selected it in this case. So you give it a name, let's call it GM4 for instance, and then say OK. And that then creates that program. And it immediately goes to the information it requires regarding the blank. I'm sort of come out of that for the moment, because we've got back into the edit mode. What was that? There we are. So if I go to flange, this flange program is one we created earlier. The little arrow key here indicates if we go right on the arrows, we've got the program there. Here you can see we've got two points here. where we've added a little bit of manual code. You don't have to, but sometimes you prefer to. So the little plus, if I press the plus key, it opens that out. So I've got those 4 lines of normal G code.
So they were manually input, were they?
Those are manually input. And likewise, I've go down a bit further, this Kanuki, and then arrow key, I can open it there. And again, you can see there we've got lots of G code.
Yeah.
And again, it's a personal preference as to whether you use that or just use the
graphics.
The shop mill, Shopturn as it comes in. Then we've got the drilling. So this is actually stock removal and turning for a flange. You've got the menu there. You fill in the blanks just like you did on the ISO. And then once you've done that, you accept it. And then we come down, we've selected from the drilling menu, we selected the actual drilling centric, and then we did we filled in the information there. I'm just going to cancel that out. Below it, then we tell it the PCD of holes in this case. So again, it's just a case of filling in the blanks in really. He's got 12 holes, 16 degrees apart, on a radius of 175, and he's doing it on the front up here. If I just toggle that, you can see you can do it on the rear, the front, and that depends on the type of drill. If you get a side one, you can do it on the side. Just cancel that out. So we have our program, and we now select the simulation down the bottom here, and immediately the screen goes into its simulation mode, and it's loading the data up. And there we have the flange we want to generate. You can see the actual program going through. I'm just going to put a single block on there. I've got details here, and there I can actually zoom up or down. So I'm going to actually zoom up. Now okay, it's gone off the screen, but I can actually now manipulate that up and down to bring it into the screen, and I can actually zoom up again. So there you can see it's drilling the hole and it's rotating around the C-axis, and that's the last hole actually. So here we've got the solid graphics. You might want to have a view of the actual through the side view in effect. So if I select side view, you can see the side view there. You've got further views just while you're at it. You can have a face view, what terms of half cut view, which again is a side view. You can see here the holes, because this has been processed already. I'll go back, I can reset it, I can do a cycle start, and now you'll see it all go through again. And it's maintained the actual zoom we'd created in the first instance. So there you can see the drill. Now you might notice you're not seeing the drill going through fully because you're not seeing anything. It's going in and out. You won't get that till it finishes, but basically it's because it's doing the C-axis straight away. So once it finishes, and down the bottom, by the way, you've got all the data coming through here. So there we are, it's finished now, so you can see where the hole is. It's not quite breaking through, so if required, we could always modify the program to go a little bit deeper. Right, so that's the completed graphics. Basically, this control is quite it's a very powerful control as such. It's easy to operate. It's designed for programming on the shop floor or offline. So you can use your G code, you can use the Shopturn, and whichever way you can get your programs in the machine and producing parts quickly.
Right, we're now going to run the actual program that we generated there with the Shopturn. So we'll bring the control up, that's on a moving slide. So we're seeing the turning function. And then the grooving function. Then we'll index the turret round, and we'll bring in the driven tooling and the C-axis, and do the series of PCD hole drilling. As we run through the program.
You can actually see the actual ISO program there, which is coming off the actual Shopturn program.
Right. And that then just completes the drilling.